Welcome to lesson 3.2. 3.2 says this: I can draw particle pictures representing sections of a heating slash cooling curve, and today we'll be specifically focusing on a heating curve. So before you hear, we see a heating curve, and the way that we know it's a heating curve is because the graph is showing us that temperature increases as the graph goes up, and we clearly see an overall upward trend from left to right. Hence, there's a heating curve. So something we need to jump into today is the notion of temperature and energy. So what does it mean when temperature increases? It means that energy is also increasing. So along with energy, we know that particle motion is increasing. And we also know that sometimes particle spacing will increase. So here at the bottom, we're going to write a key point off right in the bat that should go into your notebook. When energy enters a system, of water specifically, it can do one of two things. It's either going to raise temperature, or what it's going to do is increase spacing, increase particle spacing specifically. Energy does not have the ability, and I repeat, it does not have the ability to do both of these things at the same time. As we look at our graph, we see that this is evident. Either we're increasing temperature or we're changing phase. Increasing temperature, changing phase, or finally increasing temperature. So what we want to write down here is that never happens. So both never happen at the same time. Remember, when temperature raises or declines, we have a single phase of matter. So single phase of matter. Let's go ahead and let's highlight this to the graph. All right, so here's our yellow highlighter. So here's a temperature increase. There's another one. And then here's our final one. And please try to remember now that when we have an increase in particle spacing, this is where we have two phases of matter. Remember, this was called a phase change. So now we have our other highlighter, and let's go ahead and highlight this again to the corresponding pieces of the graph. So let's find our phase changes up north. All right, there's one, and then there's the other. So now what we'll do is try to particle draw each of these individual points We'll add one here in the middle, and we'll go through each and every one of these as a particle drawing. We want to add our key temps. So remember, 0 degrees C, room temp, 25 degrees C, and then our boiling temp, 100 degrees C. Go ahead and make some particle boxes for every point. So here's going to be box for A. Here's our box for B. They don't have to be perfect. Just try your best. Box for C. We'll do this little midpoint here. We'll draw another one. Here's one more box. Here's a box for D. Here's a box for E. And then here's going to be a box for F. So now I'm going to switch colors. Blue to represent water. And we're going to get started here on box A. We need to conserve mass at every box. So we're going to go with 3 particles at every box. When we look at box A, we are well below the freezing point of water. Hence, that tells us that we're going to have to draw a solid. So we're going to put our 3 particles together. And we're going to put some vibration marks. And the reason for that is, even though something's a solid, on the microscopic scale and on the atomic scale, it actually is still moving. It's not moving about, but it's vibrating in one spot. So then we move up the graph. I see I hit my first flat part. This tells me that I'm starting again to a phase change. So in this box, I'm going to have to not only draw a solid, but a liquid. So let's go ahead and do that. So we'll draw a little solid piece here, the little vibration marks. And then we want to draw something called the liquid line. And we're going to draw our first particle of liquid in that box. As the phase change continues, all of this solid will end up melting, and at point C, we're going to be finally a liquid completely. So here we go. Here's our liquid line. We're going to draw 3 little liquid particles. As we follow up the line from point C, we see temps increasing, but there's no phase change. So we're going to draw a liquid again, but we're going to add whooshies to show that the temperature is increasing. All right, so now from this midpoint, we'll keep going to point D, and now we hit our next flat. So this is our final phase change, and what we realize is that a liquid will have to turn or start to turn into a gas. Notice that from the midpoint to D, the temperature is increased. So we're going to add one more whooshy onto the liquid, but here at the top, we're going to draw our first gas particle beginning to emerge. As the phase change continues and completes, at point E, all we should have left is gas particles. So let's go ahead and draw that. So there's a pressure event, there is another gas particle, and there's one more. As I move from E to F, I see that the gas is getting hotter. Remember, the phase change occurred at 100, the temperature stayed put, and now we're going back up in temp. So what I need to do is draw a hotter gas. So this time, let's draw 2 pressure vents to signify a hotter gas. And that should be our final drawing for the curve. Some key things we manipulated during our particle drawing were whooshies. So in a heating curve, they went up. generally speaking. And the next thing we manipulated was particle spacing. To recap this video, in fragment A, because we're under the freezing point, we drew a solid. Point B will be the beginning of our phase change. So we know that in this green section, again, we go from solid to liquid at 0 degrees Celsius. C to D is going to be our liquid phase, so we'll draw an L right here. D begins the final phase change, so now we see our hot liquid start turning into a cooler type of gas. Point E would conclude the phase change, right? Now we have our gas with a little pressure vent, and then we know the gas is getting hotter because the graph continues to go up. So we'll put it G for gas. The inclined sections in yellow got a single type of particle drawn in those boxes. And the last thing to remember, the beginning of your phase changes or in between your phase changes will always have to have two types of particles, gas and liquid in this case, and in this box, solid and liquid. That'll conclude today's video. Please rewind as needed, and as always, have a great day. Thank you.